All right, we skipped 10.3. So if you see the 10.4 and you feel like you missed a day, you did not. We're going to go from 10.1, 10.2, skip 10.3, and go on to 10.4. And here we go. So what we're going to compare here is perimeter and area, and how does that measurement change as the size of a polygon changes from one polygon to a bigger or larger similar polygon. For instance, right now, we have a square that is 3 by 3. This square then increases to a 5 by 5 square. Now that square did not double in size, it did not triple in size. But what we can see right now is we have a scale factor and remember we find the scale factor with a ratio of corresponding sides. So the scale factor is 3 over 5. Meaning the smaller square is 3/5 the size of the bigger square. Now, what is the perimeter and the area? The perimeter is 3 times 4, which is 12, because there's 4 sides, they're each 3. The area is 3 times 3, or 3 squared, which is 9. Over here, the perimeter is 5 times 4, which is 20. The area is 5 times 5, which is 25. Now, if I took a square and I doubled its size, you might suspect that the perimeter and the area would both double. Or if I quadrupled it, or if the square got 10 times bigger, you might assume that the perimeter gets 10 times bigger and the area gets 10 times bigger. One of those assumptions would be correct. If we look at the ratio of the perimeters, we're going to get 12 over 20. If we take the ratio of the areas, that's going to be 9 over 25. 12 over 20, if I take 4 out of both of those, that simplifies back down to 3/5. 9 over 25 is 3 squared over 5 squared. So here's the relationship that we're going to use in this section. If two polygons are similar by a scale factor, then their ratio of perimeters are similar by that same scale factor. Meaning if the polygon doubles in size, the perimeter is going to double in size. But the ratio will increase by that scale factor squared. So if it triples in size, it's going to get bigger by 9 times bigger. Or if it doubles in size, it'll quadruple its area. And that's what we notice. Theorem 10.7 states just that. If a scale factor is A over B, then its ratio of perimeters is also A over B, but its areas is A squared over B squared. The trapezoids at the right are similar. The ratios of the lengths of the corresponding sides is 6 to 9. So they took these two corresponding sides and they gave us a scale factor. So what is the ratio of the perimeters? Well, that's also going to be 6 to 9. We could simplify that down to 2 over 3. What is the ratio of the areas? Well, that's going to be 6 squared over 9 squared. So 36 over 81. So this could also be 2 over 3, or this can be 4 over 9. All right, two similar polygons have corresponding side ratios of 5 to 7. So their perimeters are also going to be 5 to 7. Their areas are going to be 5 squared to 7 squared. So 25 to 49. That doesn't mean that's what their areas are. That just means that if we take their two areas and make a ratio out of them, they'll simplify down to 25 to 40 compared to 49. All right, the area of the smaller regular pentagon. So they're giving us the area. What is the best approximation for the area of the larger? So larger, smaller. And since we are dealing with area, when we do 4 over 10, we need, because that's the scale factor, we need to do 4 squared and 10 squared. Since 27.5 is the smaller, that's going to go up top. And the x goes down below. So this is 16 over 100 equals 27.5 over x. We're going to do our cross products real quick. 16x equals 2,750. Which is 171.875 centimeters squared. All right, next one. We have a scale factor of two similar parallelograms, which is 3/4. As soon as I see that I'm dealing with area, I'm going to go ahead and square that scale factor. So now I'm dealing with a proportion trying to find a larger area, a smaller area. So the x goes up top, the 96 goes below. So this is going to be 16x equals, that's 9 times 96, which is 864. Divide that by 16, we get 54 inches squared. All right, the triangles below are similar. What is the scale factor? What is the ratio of their perimeters? So we have the two areas. So the ratio of their areas is 50 over 98. And that simplifies down to 25 over 49. That means their scale factor if this is the ratio of their areas, their scale factor equals the ratio of their perimeters, which equals the square root of 25 and the square root of 49, which is 5/7. So this little ROA is just a shortcut of writing ratio of areas, ratio of perimeters. All right, this next one. The last one wasn't something that we had to spend too much time on. There is one thing I want to point out about that last one. 50 and 98, they're not perfect squares. I went ahead and I simplified the 25 down to 25 and 49 because I knew I was going to be taking the square root of them. You could just do 50 over 98, hit math, enter, enter, and get that down to expose the two perfect squares. But watch what happens in this next one. If the ratio of the areas equals 1875 over 135, that comes down to 125 over 9. So the ratio of the perimeters is going to equal the square root of 125 over the square root of 9. Which equals, now 125 is not a perfect square. So we can just leave it as the square root of 125 over 3. Now, if you would have done 135 over 1875, now watch what happens. The square root of 9 over the square root of 125, that equals 3 over the square root of 125. And we cannot leave a square root in the denominator. So I need to multiply both the top and bottom by the square root of 125. This is rationalizing the denominator. So this is going to equal 3 times the square root of 125 over 125. And of course, we can take that a little bit further because we know inside of 125 is a 25. So this is really 3 times 5 times the square root of 5 over 125. And then that cancels out. And we can end with 3 roots of 5 over 25. The problem did not state if we should do smaller to larger or larger to smaller, which would have dictated should I set it up with the bigger number on top or the bigger number on the bottom. There clearly was a difference in the amount of work that's shown. But if you look at the top one, or maybe that was the previous problem, I think it was one of these. Find it right here. Smaller to larger, smaller to larger. If it states that, then we are forced to write it in a certain way. So just keep an eye out for that. If it doesn't state that, then obviously choose the shorter way. But keep in mind, if this was a multiple choice question, then one of the answers, you might have been forced to do it by putting the scale factor in a certain orientation. All right, go ahead and practice those homework problems. Tune into the office hours. Take the exit ticket. Make sure you guys are asking all your questions. We're winding down here to the end of the semester. So keep following along. Keep doing what's expected of you guys, and let's finish up strong. Okay? We'll see you.